Our speaker tonight, among his previous roles, has worked at IBM and Lucent Technologies. He was also among the initial developers of VoltDB's commercial product. Please welcome, what's so funny?
That's a fine introduction. Nothing funny at all.
Oh, okay. No, I wasn't. Okay. Please do welcome the CTO of VoltDB, Ryan Betts.
Please have this microphone well adjusted. I can be heard. Yeah. All right. So, welcome everyone. I'm sorry I can't be more in the middle of the room. I'll try to pay equal attention. My name is Ryan. I am one of the original developers of VoltDB. This presentation tonight is sort of the product of myself and Ariel Weisberg, another one of the core Volt developers. So why do I do what I do? This is really kind of what motivates me. I think that if you build a product and a company around it that accomplishes something, that makes something that wasn't possible before, that in some teensy, tiny, and hopefully positive way, you change the world. That's what I like to do. I like this sort of personal mission statement, but at the same time, honestly, it feels a little kind of full of hubris, which I don't like. That's the teensy bit, little modifier. Between Ariel and myself, we represent about 2/3 of the original VoltDB product team. The other third, John Hug, is still at Volt. For the last 5+ years, the three of us have been working on making transactions really, really fast. So database transactions kind of as fast as you want them. Hundreds of thousands of them per server. All of them pure SQL, multi-SQL statement. We've done a lot of distributed systems work between us before this. Ariel in particular is what I call our hardcore I/O guy. They say that you should start every presentation with a joke. This is my joke. When Ariel sneezes, it sounds like sing. All right. That's my only joke, okay? That's it. So if you don't laugh at that one, it's going to be a very long night for you guys. I'm sorry. So what's this presentation about? This presentation is titled Bridging the Gap. If you knew me, well, you would know that I could not have possibly avoided the pun mind the gap. Ariel titled this presentation, and so it's called Bridging the Gap. What is the gap that we're going to talk about bridging? Well, fundamentally, when your problem size reaches a certain scale, you have to start specializing. And when you specialize, the things that you are specializing with, they don't fit together quite perfectly, right? And it's that missing fit that we're going to talk about. That's sort of the gap that we're discussing. In particular, we're going to limit the conversation today to what happens when you specialize to explore your data, to analyze your data, ingest data, and transact against it, the OLTP portion. Of course, there are lots of other problems that one can specialize for. They're just sort of out of scope, but they fit the same theme, right? So you could specialize your problem around a graph solution, right? You could take a graphing approach. There's text search, Elasticsearch, audio, video, different statistical modeling. There's lots of different kinds of specialization. But today we're going to focus on those large 4 areas. So when do you start thinking about specialization? So first off, how many people here work with data pretty much every day as either, all right, most. How many of you here make a database for a living? The poor suffering queue. All right. How many people here work somewhere where you specialize databases, where you have some solution where you had to move off of kind of a one-size-fits-all classical solution, and maybe you started specializing first with caches, right? Then maybe you start splitting up between a transaction system and an analytics system. People here running both transactions, analytics, and separate systems. Yes, okay. So when do you reach that point, right? So for me, the answer, when I go to a lot of hackathons, I get asked to judge hackathons and participate in some of them, and there's something really fascinating. As soon as a problem doesn't fit on a laptop, like half the audience immediately just gets lost, right? They move into a realm where their tools just don't work for them anymore, right? If you can't solve the problem with Python or a bunch of Python in your laptop, then all of a sudden they start searching for tools they're not familiar with. So I think to some extent, in a way, your data is big when it doesn't fit on your laptop. It sounds kind of silly, but honestly, you see lots of problems every day where people apply a ton of technology to something that's basically a terabyte, and a few thousand transactions a second and some analytics, and you could go assemble more or less free tools or definition here. Your data is big when if you specialize tools, you can make more money. Right? This happens a lot too. And this is really maybe more the motivation that we see. If you're our CMO, your data is big when it starts falling out of this barrel. I really like this picture. I lied. I have 2 jokes in this presentation. I'm going to tell the second one now. I'm comparing you. All right. So my favorite part of this picture is this yellow goo kind of up here on the right. I have no idea what that goo is, but whoever added this goo to this pipeline, that's the only guy that did something right. That's the only part of this pipeline that's not leaking. Yeah, it didn't work the first time I told it either, so sorry about that. You know, there's a really interesting opportunity to apply new tools to not just do something better, but really, indeed, to make more money. As an example I've been using lately that I really like, we've been working with more and more game companies at VoltDB to help them monetize in-game play. If you think about it, games were originally kind of pay to play, right? You either paid a subscriber fee or you just paid outright for the game. And kind of how much you played the game didn't matter a ton. Right now, the games are really paid while you play. Right? You download a game, it's free, especially on an iPhone or an Android phone. Once you start playing, that game manufacturer needs to entice you, right, with a customized experience to fork over your hard-earned cash for something that's completely ethereal and fake. Right? That's not an easy problem. And it turns out that that is a problem around data specialization. Right? They have to be able to understand what's going on in that game in real time. Those games are extremely heavily monitored and instrumented, and they're personalized to players on an ongoing basis throughout the day based upon current game state, the current revenue production, the current people online, features that are being A/B tested, right, as the game rolls out. In this case, you're actually looking at data specialization tools that are enabling a new business model. They're changing the way that these game developers generate revenue. Right? No longer are you paying for the game and then playing it an arbitrary amount. Instead, you're applying better data management practices, right, kind of at the low level, in order to entice people to give you money. And so that's kind of the specialization when you can make more money aspect of this. Game is one example. We're seeing data, of course, generated at fast rates across vertical after vertical. This slide projects that by 2020, something like 85% of automobiles will be connected. This means that they'll either have intelligent sort of drive analytics insurance things. There's a word for that I can't think of. It's in my notes. Usage-based insurance. They'll have stolen vehicle recovery, right? They'll have networking for real-time traffic. They'll have all kinds of entertainment that's being integrated, right? I've seen a ton of information from Apple about that lately. 1.8 billion automotive end-to-end connections, right? That's a lot of data being generated. Another trick question here, how many fingers does Count Dracula have? I noticed this on the train up here, and it's kind of blowing my mind. How could the Count not have 5 fingers, right? No. Apparently he has 3 and sort of a midget thumb. I don't know. So I guess he doesn't count to 10. Maybe it's the octal count. So I love this slide, not because it's about databases, but because I just love the idea that somehow your revenue is proportional to your data. Who thinks that's true? This is a tough audience. I don't think it's true. I talk to people all the time who generate data. The problem they have is how do they generate value from that data, right? And that's another gap that's important to keep in mind as you begin to specialize. If you know of a situation where you can just generate more data and then generate more money, then I would like to add myself to that particular job offer list. So I can generate data really, really fast, all right? Generating money is harder. Smart grid, the number of smart meters that are being rolled out is really fascinating. This is, I think, kind of a quiet but very thorough change, and it's a worldwide change. So something like 500 million monitored meters are going to be rolled out in China, 60 to 80 million or something like that in the UK. It's projected that in Europe by 2020, over 85% of all electric meters will be read remotely. Right? They'll all be smart meters. This is really interesting. It also impacts the way that electricity is priced, the way that electricity is delivered, the way that we start guiding into electricity subsystems for things like electric vehicles and transportation. And it's another great example where just because you have a lot of data doesn't mean you have a lot of value, right? So these are some examples where data is being generated where there are challenges of scale. I talked about gaming, talked about smart grids. I'm in New York. I should just probably say that finance generates data just because I'm here. Here's the slide I had to add. I just couldn't stand the title of this presentation, wasn't Mind the Gap. Let's talk a little bit about some of what the gap is. Right? So as you begin to specialize your databases, what are some of the different sort of impedance mismatches that you have to take into account? We're going to walk through the 4 different areas: analytics, exploration, ingest, and transacting. And we're going to look at how some different systems and some different combinations of systems create better or worse solutions to sort of the combination of those 4 aspects. So, analytics, OLAP. For the purpose of this presentation, analytics really implies that you know your queries, right? We're going to separate the idea from analytics from the idea of just random exploration. There are a lot of use cases where you generate data, you ingest it, and then you need to be able to group it on a very regular basis, and you're going to use the results of that grouping. You know, it could be a large set of data, hundreds of gigabytes, many terabytes. If it's the index of the web, it's even substantially larger than many terabytes. And you use that to drive some value, right? To either customize some experience, to answer questions, to be able to answer questions with some kind of high level of concurrency. So the process of generating that intermediate result set, that's what we're going to term analytics. When you're doing analytics, you know your queries, you know your data, you can index, you can materialize partial results for better efficiency, right? This is really in contrast to exploration. When you're exploring, right, really what you're doing is you're asking kind of unasked questions of raw data. There are a lot of really interesting products that are being made around exploration. I think one of the better demos I have seen on this is the Rubicon project from the New Relic guys, the monitoring guys. They give a really compelling demonstration of this. And what's interesting is that it demonstrates the difference between exploration and analytics. When someone sits down to explore, they want to be able to ask a series of questions and get back immediate responses. And they don't want to have long programming interruptions, pause them between asking one question and the next, right? They really want sort of a Socratic method of inquiry against their data. They like to be able to ask, who was on my website last month? Well, what were they doing? Well, what were their ages, and what time of day was that, right? You begin asking a sequence of questions. These aren't questions that you're likely to repeat very frequently, although your exploration may lead you to some kind of data that you would repeatedly generate over time, right? You might turn or create an analytical process out of this exploration. Exploration, though, is fundamentally queries against raw data. In this case, you can't prepare much, right? The fact that you're not really sure what questions you'd like to ask or what you'd like to explore limits what you can prepare. So, ingest. And all of these sort of smart applications, anywhere or any kind of log application, anything you're collecting logs from a web tier, you have essentially an ingest problem. You have generated piles of data, and you just want to be able to collect it and bring it back to some source so that you can run these analytic and these exploration queries. And ingest is something I think that people are really struggling to figure out. We've seen whole bunches of different applications as sort of tries to find something that developers like for ingest. We've tried databases, right? We've tried tools like optimized databases like HBase. There have been a number of streaming tools that have come to market that treat this ingest as sort of a stream processing problem. So what are the aspects of ingest that are important? It's almost obviously all insert or append or append only. And most interestingly, most of the writes that you're generating, you don't need to go read a value first, right? It really is append only. You're not transacting as you ingest, you're really just recording, right? Maybe you're transforming, maybe you're taking a log file, splitting it into individual events, right? But largely, the database, the data management workload behind this is one of recording. This is really in contrast to transaction processing. Right? So transaction processing share something with ingestion. It's also a write-intensive process, right? You're mutating your data very rapidly, and you're generating a lot of writes. However, it's also a very read-intensive process, right? You're reading values in order to transact against them. Think about it as incrementing or decrementing. These are all read and then write patterns, right? And these are all fundamentally transaction patterns. So sometimes when I talk through this, the difference between ingest and OLTP gets muddled, probably due to my poor communication skills. And sometimes the difference between exploration and analytics gets muddled, right? And I'm not saying that there are four always discrete camps and something's always in one, but I think it's important to be able to characterize a problem into some set of aspects, and I think these are four aspects that apply relatively broadly. And of course, all the things I've talked about for OLTP require transactions. So coming back to the main theme of the presentation, when you can't solve all four of these problems in just one tool, well, what do you do? So Twitter recently announced a project they call Manhattan, which led me to ask a very deep and meaningful question. If you have 4 presents and you want to give them to someone, and you have 1 box, and you wrap them all in the same box, how many presents have you given them? 1? 4? I don't know. I want credit for all of them, personally. You guys are at 3 jokes. 3. Come on. So, 1, 4, I don't know. It's kind of an interesting point. So, what Twitter has done in this case is they've said, well, for our particular use case, we have specializations that we would like to make. We would like to expose all of these as kind of a consistent data service because of the way that we run our business internally. But they specialized for insert-heavy workloads. They've specialized for eventual consistency. They've allowed the option of strict consistency. There's still not a strong transaction story here. They claim transactions, but basically on the ability to do a compare and swap operation, and anyone who's tried to write complex transactions on top of just a compare and swap primitive knows how painful that is and how inefficient it is for developers. There are both row store and column store aspects to this, right? So there's still a lot of specialization involved in this. And the gaps that we're going to talk about, you'll find those gaps evident in this architecture as well. Is this making any sense? I need some audience feedback here. No? Yes? Come on. So, all right. I think this is what I get for standing at one far end of the room. I don't know. So let's walk through and look at what happens when you start with one size fits all. Right? So these are tools that everyone knows. Okay, so I'm going to re-engage the trivia, but with nothing to throw at you, so you can feel safe. When were these databases started? When were the initial releases of MySQL and Postgres? 1990. Yeah. And when was the first release of Oracle?
1983.
Yeah, early 80s, depends on kind of how you count. I think it's fascinating just think how old Oracle is. Ancient, decrepit, piles of money, right? Yeah, it's good and bad. So I was surprised. One of the, we were thinking through just sort of the timing of some of these different products recently, and I know I used early versions of MySQL, and I can't believe that it was 1990. It felt like it should have been much longer. It's like there should be a lot more history between the mid-90s, the early 90s, and now. But so when you specialize, when you have a single system and you begin not to be able to fit all of your workload into it, you start to do different things. So for example, a very common pattern if you'd like to run analytics or read-intensive workloads against your kind of one-size-fits-all classic database is you begin producing read replicas. Right? Now, different databases have different read replica strategies. For example, Oracle, you can do SQL caching with times 10, right? You create a cloud of times 10 servers. You can have a standing query basically that feeds them information, and then you can do your reads off of those in-memory things. You can basically shard them horizontally to scale the throughput capability of those reads. You can do something really similar with Postgres, and kind of similar with MySQL. Where's the gap in this? Well, in one case, you really haven't answered a number of questions. You haven't really solved an ingest problem, right? You're still limited. You have to keep those read slaves up to date, right? And you have to solve the ingest problem with the original server. You're still probably not ingesting at hundreds of thousands of units of information per second. right? It can be limited to sort of the transaction profile, transaction throughput of the one system. Your analytics and your reads haven't really been specialized by storage format, right? You're still kind of storing this data in the same way that it's stored. You're not optimizing, for example, column store for analytics, right? In the same way that you're not really optimizing like log structured merge trees for the ingest, where you can do append-only operations instead of updated place. So you end up being able to scale out some of the analytic workload, right? But you still haven't really solved the full problem, and so that's kind of what we mean by a gap. Fundamentally, nothing's really been optimized in this solution, right? You haven't optimized a solution for OLTP. You haven't optimized it for analytics. You've really just kind of created a band-aid that lets you scale out some of the analytic workload. And in that scale out is really still kind of a second-class citizen, right? You're able to horizontally scale out some of the rate-intensive aspects of this platform, but the write-intensive aspects aren't scaling for you. So you can take another approach to this. You can say, I know something that's really cool, and it has an elephant in it too. I can use Hadoop, right? So in this case, you say, okay, I'm going to step away, and I'm going to begin to specialize my systems off of sort of the classic one-size-fits-all, and I'm going to introduce some new technology. In particular, I'm going to use Hadoop as my analytic and my exploration platform, right? And I'm going to use HBase as my ingest platform. You're getting closer, right? In particular, just stay on the slide for a second. So in particular, Hadoop is going to give you a lot of spindles that you can read in parallel, right? For some of these analytic queries, it's going to make scanning your data a highly parallelized operation. HBase is going to make insertions relatively fast, right? Because you can just do append-only insertion into HBase without a lot of expense, and that's also going to be able to scale out horizontally for you. So you're starting to kind of gain some traction around these four problems. So when you look at this, I guess I could have just gone through this slide, is what I just said. So when you look at this, where's the gap? The gap, I think, is in kind of a surprising place for some people. The gap is really around the analytics portion, right? So MapReduce is really a crappy, inefficient way of doing analytics, right? When you think about what you want to specialize to make analytics really fast, you want to be able to do novel things like create an index, or maybe pre-materialize some data that you're going to read over and over again, right? The idea that you need to scan all of this data over and over again, and every time you're going to transfer large portions of intermediate aggregates back to your reducers, and probably you're going to chain those things together many times, you end up with a system that's very computationally inefficient for analytics. And this is something that I think people who've used MapReduce a lot are beginning to realize. There's some great tools coming out that I think work around some of this problem. There's a ton of SQL on Hadoop projects that are coming out that are using more specialized column formats, right, to speed up some of this. Another trivia question: Who can name a SQL on Hadoop technology? It's actually one of my personal favorites. And Paula's a good one. A while ago, one of these products was announced. Presto was announced, and I was in a snarky mood, which is actually pretty unlike me. I'm a nice guy, and I tweeted out something like "Welcome to the SQL party, Hadoop," which I regretted almost immediately after having hit the tweet button. And I got back these responses like, "We've been doing SQL since, I don't know, not 1995, but since Hive." Right? So I thought, that's awesome. The kind of the premier flagship NoSQL product is now tweeting back to me that they've done SQL since, apparently this isn't a good fifth joke either. So anyway, my point here, does this resonate? Anyone does anyone here do scanning analytics with MapReduce? How's it work? Yeah? What would you do instead? I don't mean to put you on the spot. You can just say I'm a jerk and like pass, but.
When I'm doing copy stuff, I'll just pull it totally out of the database and run it on.
Your laptop? Yeah. That's a great answer. So if you're wanting something complex, right, you extract the data out. You're basically performing kind of a brute force ETL process, and you're working with it somewhere more comfortable, right? Is that a fair summary? Are there any other experiences around analytics with MapReduce? Actually, I'm asking this for my own kind of edification as well, but I am sure that looking at this room that my experience here is dwarfed by at least just Evan, so I know one of the participants here. No other horror stories to share here? Okay, so in this case, you've really solved a fair number of problems, to be fair, right? You've solved the ingest problem. You're successfully writing your data to a data store that's probably not going to lose it. You managed to scale that write workload out, right? If your ingestion workload is greater than that which can be accomplished by a single database instance, traditional database instance, then you can add more servers to add more write throughputs to your database. You've given yourself at least one nice hammer to do analytics with, but it's a pretty crude hammer if those analytics want to be efficient and heavily repeating. And you've given yourself some method to do exploration with, but I think that exploration method, while relatively efficient, maybe from kind of a disk I/O perspective, is less efficient from sort of that mental process. I was talking about the Rubicon New Relic project. You watch this guy's demo that. It is really, truly amazing that when you can ask kind of an arbitrary question and get back an answer in a matter of seconds, instead of having to write a program and then, for me, debug it for an hour and then run it, and then get back an answer in order to think about what the next question you want to ask is. Like, just the way that the mind works, it really likes just to be able to ask questions really rapidly and see results really rapidly. And so you can do this exploration process here, but I think that some of the emerging SQL and Hadoop projects, whether it's, I think Impala got mentioned, there's Dremel, there's, I don't know, maybe there's just one called Drill, or maybe, right? Yeah, another good one, Parquet file format, right? There's a whole plethora of them coming out. I think that they're going to make some of this exploration process a little bit easier also.
When you say ingest, though, there is really only a pen mode, right? It's not.
Right. Right. You're not transacting against that data, right? You know, there's this is I think another really interesting conversation to have, if I can entice the people in the room to have a conversation, and that's what do you think? Like, is ingest really just an append-only problem, or is there interesting transacting and decisioning to be done while ingesting? Right. So I have a particular answer to this because I happen to make a really fast transactional database. I'm always trying to convince people that transactions on ingest is super important. And I tell stories like, you want to be able to send alerts and alarms immediately without having to post-process for analytics, which sounds really compelling to me. I don't know if it sounds compelling to you. Or, what if one of your partners stopped providing you data, right? And you would like to know that immediately or what if they start providing you corrupt data? And you would like to find that out before you write it all to your warehouse, then need to go clean it up? Or what if you would just like to see real-time analytics, simple counts and aggregates to drive BI and dashboard against that incoming stream? Right? Is that useful? So at the moment, most people who are solving ingest solve it with a relatively crude append-only mode. Right? That was kind of. I think that as the connections between partners and data sources become richer, I think that there's going to be a growing need to actually be able to transact against that ingest process so that you can apply real-time transformation, real-time alerting, real-time sessionization. There are a lot of ingest problems that kind of turn into fancy upsert problems too. You want to maintain some table of state, like last location is a really common one. I was talking to someone recently that is putting RFIDs on every item in a clothing store. Okay, I have a sixth joke for you. My joke here is that once you do that, you also need to wrap your underwear in tinfoil hats, right? All right, giggles, getting a little better. So it's really cool. So it turns out there's two things about this problem that to me are amazing. One is that it's of interest to know the exact location of every item in a store. Okay, I guess. I've never really worked in a retail store, so maybe I'm underestimating how painful inventory is. The other thing that's really interesting to me about this is exactly how crappy the bandwidth is from retail stores back to the cloud. You basically are sharing like a T1 at best. A lot of these guys who are doing sort of in-store things are deploying their own mobile networks, and right, so that they can send at least data over an LTE network, and that's assuming that they can get some kind of cell reception buried deep inside the mall. This leads to a couple of really interesting problems for them that are related to whether ingest is an intelligent data processing problem or whether it's really only append only, it turns out, shockingly, that most underwear doesn't really move of its own volition around the store, right? It's kind of just frozen in place for long periods of time, and that's not interesting. It's only interesting when something moves, right? So in this case, what they want to do is, as they're ingesting this data, they really just want to be able to record things that have moved recently. Right? The rest of that data they would just like to drop. So they can't just basically raw append all of this stuff and then send it off somewhere else to post-process or ETL, because they don't have the bandwidth out of the store to accomplish that. They need to do intelligent filtering at the retail establishment itself. Right? So in this case, they would argue that this ingest process actually includes a transacting kind of pre-processing portion to it, right, to perform the filter that's necessary only to capture interesting data. Kind of got off onto a tangent. But this is kind of a question and answer period at the end of this. I would love to hear people's thoughts on whether ingest is a transaction problem or an append-only problem. It's something that's of really particular interest to me. So there are other options. Instead of picking, for example, Hadoop plus HBase, you could pick Cassandra. You kind of get a similar set of trade-offs. Of course, I'm not talking a ton about consistency models here, which is a nice advantage to Cassandra's eventual consistency model if that's what you need. But simply from kind of this gap orientation, your trade-offs look a lot like kind of the HBase Hadoop trade-offs. So if you specialize, right, if you start specializing, you're not going to just kind of take like an evolutionarily better database, whether that's Hadoop and HBase or Cassandra versus your single size, one-size-fits-all database. You need some way to start tying those specialized things together. I am going to admit I have never used PostgreSQL foreign data wrappers, and I think it could be another good trivia question. Has anyone here ever used these? No? I think this is fascinating because it's just such a weird idea. Like, that basically you can use Postgres as a facade for a bunch of other data stores. I don't know what engineer thinks this kind of coupling is like brilliant. But I don't know. It's interesting. It's just an interesting idea. As you start to specialize, you need some interface to tie things together. And I'm not suggesting to you that Postgres foreign data wrappers are that interface. I just think it's interesting that someone at least has been playing with this. When I say specialized, what are some of the specializations that I mean? So Elasticsearch, or a very accomplished search tool, helps you find things in text quickly. My speaker notes blink really weirdly, but the screen doesn't. So if you see me like staring confusedly at the slide, and that's why. That helps make any sense. Netezza, Vertica, right, are great OLAP tools, great analytic tools. They've optimized for the ability to do analytics quickly. VoltDB, which I happen to think is the best database on the planet. Just saying. No, VoltDB is very much specialized towards transaction processing, right? So lots of small transactions repeated very, very frequently, hundreds of thousands, millions of times per second. Now, hypothetically, right, Postgres could be sort of the saving grace here. You could use this foreign data wrappers as your interface to all of these things, but probably no one's going to do that, right? It's not very real. It doesn't handle rollback of remote things. It's really tightly coupled. If remote systems go down, it ends up being really slow. So you need to start thinking about how not so much a facade or a single interface in front of these things, but really you need to start thinking about how does data flow through these different tools, right? And there's a very common data flow that I see over and over again, and that I think is going to become an emerging pattern. Someone will come up with some nice name for it, kind of like LAMP stack or something like that. And the pattern looks like this. You have some data source, maybe a set of sensors, a bunch of log files, and you ingest them, right? You append them to some kind of a store, at which point you then run your analytics against them. Right? Those analytics produce an intermediate result set, and you need to find some way to host that intermediate result set, right? That set of aggregates back into a database that scales reads. So I can give a financial example of this. Let's say that you're a large bank and you would like to be able, every time someone comes to interact with you about a financial product that you are using right through their institution, you would like to be able to make an offer or specialize their experience in some way. right? So what are the different pieces of data flow? Well, you have a large history that's going to help you guide the decisions of the offers that you might make, right? Kind of a really intelligent advertising problem that's industry specific. And at the same time, you have people come to your website, you need to be able to have some way of fast serving and kind of slicing and dicing that set of aggregates to make a decision sort of in real time while they're on the site. So that decision has to scale to a large number of concurrent users, right? The full set of users accessing this service. And it needs to allow high concurrency access to this relatively large data set, like a terabyte or so, right? So that's sort of a very simple and very common data flow that we see repeated over and over and over again. Ingest, store, you explore, you decide that some kind of analytics is worth repeating, you set up some kind of a process to repeat that analytic, you generate some intermediate data set out of that, and now you need to offer some scalable way for people to access and transact against that intermediate data set to drive other decisions, right? So we think about this very much as kind of a pipelining process. I'm going to propose another way to look at this using what we call VoltDB export. I think that you'll see more and more products begin to add kind of export-like technology. This is essentially like an ongoing or a real-time ETL, right? That process that I described, you could build that just with a set of kind of static or batched ETL processes. It turns out that reducing the latency of the ETL process is very interesting from a business point of view. You don't want to have to wait an hour or a day or whatever your ETL cycle is to oh, they're leaving. That's tough. So, the child can't leave. I draw the line. So they want to make this an ongoing and a continuous process, right? So I think you're going to start seeing the capability of doing real-time ETL, right? Streaming ETL. So, one thing that we do is we can ingest data into Volt. We allow you to write it to an export table, just kind of like a hookup to an ETL destination or a sink. And then we can stream that data to Hadoop, Netezza, Vertica, or Kafka, where you can use sort of those specialized tools for analytics and OLAP. Is this talk that bad? Where you can use those tools for specialized analytics, generate those result sets, and then feed them back into your serving system, which could be Volt or could be another database specialized for fast reads. So kind of the way this works is, as I described, you're transacting. You can be writing transactional records to your normal relational tables. You can be writing transformed results of those. A common example is a session begins, you update. When that session terminates, right? Maybe that entire session lasts a minute or two. It's someone's clickstream through your website or something like that. You want to recognize that it's terminated, and you would like to bundle that session together into one unit and archive that. Right? If you were to archive all of the individual events, maybe you would have to then go and ETL them all off of your Hadoop instance or off of that OLAP instance. Right? That's really work you can offload from that OLAP instance. And you can sessionize in real time, and you can reduce the latency and the time to visibility of the result of that data. So we can flow data through and eventually store it. And when you're doing this kind of real-time ETL, we talked about kind of jokingly about the tight coupling in Postgres. One nice aspect of looking at this as a pipelining project, trying to solve the problem of kind of specializing but not creating these excessive gaps between these products. You need to find some way to loosely couple. And so I think that whatever sort of your ingest is, whatever this ETL process is, it needs to have some story around how it buffers, right? And so in this case, as an example, VoltDB's export process, if you get disconnected from your OLAP sync, it will very nicely buffer this stuff to disk and then respool it out once the connection has been reestablished, right? So you kind of get a nice pipeline and a nice coupling aspect where these systems are truly independent from one another in terms of their failure and recovery semantics, right? And really what you have is a durability handoff. So until this data has been successfully transferred downstream, right, the ingesting system maintains the durability contract for it, guarantees that it'll be replicated and available. Once it's handed off, then you can actually kind of transfer the responsibility for durability downstream to the longer-term persistent store. I'm not going to walk through all of the details details of kind of how this works. There's another really interesting pattern that's another way of specializing that we kind of built a little bit as a whim, but we've seen a lot of traction around, kind of surprisingly. And that's, instead of archiving all of the actual raw data that's coming through, using this kind of real-time ETL process to generate a notification system. So as you're ingesting, there are a number of different transactions that you would like to run against that ingest stream to look for notifications or alarms or alerts, right? It might be interesting to you to know if you're doing inventory that something really expensive just walked out of the store, right? That might be something you would like to alarm on without needing to wait a really long time for an ETL process. In this case, you can export business action would result from the notification, whether that's alerting an operator that maybe they need to go like reboot something that Cisco made, or whether it's something that's mechanized, right? So for example, in a smart meter infrastructure, you may realize that some meter reading indicates that something on a pole is about to blow up. The operator can't respond in time. You need to have an intelligent decision that is basically mechanized. I don't feel like I said that very clearly. Did I get my point across? Or? Yeah. All right. Good enough. So anyway, my point is that once you begin, my broader point is that once you begin to look at this problem of specialization as a problem of pipelining, you have an opportunity to add other aspects to this pipeline that aren't strictly related to the persistence or analytics of data, but that start building more intelligent applications. And this kind of example of notification is one of those. So what are the benefits of specialization or this particular pipelining approach? So you get to basically use the best tool in each category. That recognizes a number of different benefits. One is there's a pretty substantial just TCO cost amount of hardware you need. Some of these tools are 100x plus more efficient than their peers at their particular task. As a real-world example, we've replaced 100 plus instances of sharded MySQL and Redis with fewer than 6 Volt nodes, right? So that's a really substantial decrease in hardware once you start using a transaction tool instead of to scale, right? That specializes instead of kind of a sharded one-size-fits-all tool. You can start to push. When you're ingesting data, you can't do a lot of really small frequent writes typically to some of the specialized OLAP tools, right? You need to be able to present kind of more small batches or small windows of data to them, and so as you pipeline, you can begin to do that. You can begin to format data so that it flows through the pipeline in a way that matches the expectations of the downstream systems. You can start to get real-time analytics. As you're streaming data through these systems, you can use techniques like materialized views, or some people call this incremental map reduce, right? You can start building, or like Storm, kind of CEP-ish kinds of things, right? That every time a tuple visits a particular processor, it's updating some kind of in-memory state. You're maintaining a set of running aggregates that allow you to get visibility, dashboarding, and business intelligence capabilities that show you what's happening in this kind of fast, big data architecture in real time, right? This is a benefit that you don't get without specializing tools. You can get, basically, this is the kind of argument, you get the best-in-class analytics for each case. If you, for example, look at the performance of a tool like Vertica versus MapReduce, for things where Vertica is a really good fit, so column-oriented analytics, it absolutely will destroy it on any kind of a performance profile, right? It's not even close. So you get scale, you get performance, you get a number of great benefits. So I want to kind of come back, and I really prefer, like, I think I'm a fascinating person, but I'm sure more than 50 or so of you might not think that. So I would really like to hear more stories around places where people have specialized, or where they've tried and failed, or they've tried and succeeded. Does anyone want to share a story like that? No is an okay answer. I've had 39 years of rejection every day, so no. Okay. Well, no. Okay. So when do you specialize? What do you what to do when you don't know, right? maybe that's the response I can take from the audience that asks, when do you specialize? And I hear silence. So I'm just going to assume that maybe you would like to know what to do when you don't know, right? So what do you do when you don't know? Well, I think one thing you do is you don't try to boil the whole ocean, right? You can't go and start just trying to create the perfect system. Another advantage of building things in our pipeline is you can make nice incremental progress, right? You can carve off one small data feed, you can carve off one particular analytic aspect, one particular notification or transaction on ingest kind of problem, and you can solve it independently, right? You begin to build a set of cooperating systems. You don't need to just throw what you have away and start from scratch, right? So take small steps. Think about this very much as an ecosystem of tools that need to fit together, right? Like that's the next point, is that specialization is absolutely the way to solve this. You won't find a single product of any particular category that will be able to accomplish all 4 of these main tasks, as well as a set of specialized tools, right? You can't take, for example, just HBase, or just Cassandra, or just Volt, or just Vertica, and try to build on top of that one tool a platform that will scale transaction, ingest, exploration, analytics, and then not to mention all the things that we're not talking about today, like text search and graph, et cetera, et cetera, et cetera, right? So think about this very much as a set of cooperating tools, and think about the failure semantics and the operational semantics between those tools, right? Think about how data will flow between them. Think about what tool has responsibility for data at different portions of that data's life cycle, right? These are the kinds of questions that you need to begin to ask yourself as you try to do this. You can also look at, kind of go back to the characterization of these 4 different problems and ask yourself, what part of my particular pipeline problem is append-only, right? And what are some of the technologies that scale that append-only aspect? What part actually requires transactions? What portion of that is best benefited by eventual consistency? Where is availability more important to me than perhaps a rich transactional capability, right? These are the kinds of questions you can ask to start peeling apart the problem. And I know that, I listen to what I say, and I know that as I say this, it sounds like really mundane advice, but I probably talk to easily over 10 people a week who struggle with this problem, right? And in the real world, when you're really looking at your own messy, horrible problem, and then some smart aleck from a database company shows up and says, oh, what you really need to do is just think about ingest versus analytics. If you don't punch that person immediately, then maybe it helps a little bit. I don't know. No one's punched me yet. I think some people have wanted to, but they've all been too polite. So anyway, at some point you're always going to hit a dead end with your existing tool, and you're going to need to look beyond that. Another interesting aspect, and this is kind of talking back to just because something is linearly scalable, right? Just because you can have a lot of it, doesn't mean that it's necessarily the best hammer, right? That specialization is kind of orthogonal to linear scalability. Just because you need to be able to scale an analytics problem and you can add more spindles to it to scale with a solution that's slow and kind of bad at analytics, doesn't mean that you're making an optimal decision, right? So sometimes you need to stop and think, when is my set of data management tools, when am I solving problems kind of with the same hammer repeatedly through linear scale, or maybe I could actually make a much better solution through specialization. So I was supposed to warn Eric when I was nearing the end of this, so he could prepare for the stoning that may or may not occur. So I'm going to just kind of come back, a quick wrap up. So bridging the gap, we talked about what are some of the challenges in each problem space, analytics, ingest, right? When do you think, how do you think about combining systems to solve these problems? What are some of the benefits and disadvantages of certain particular pairings of systems, whether it's Hadoop or HBase or Cassandra or a single system like Postgres or a standalone system that you're building read slaves in front of? What are some of the differences between thinking about just taking a scalable tool, like one of those things, versus combining a pipeline of specialized tools to solve your problem? What are some of the challenges and important aspects of assembling that pipeline? Right, thinking about how those products are going to interoperate, take responsibility for data, manage failure, redeploy. Right? I hope that we managed to discuss that with some fruitfulness this afternoon. I didn't know that we were going to advertise hiring opportunities at the beginning, but I'm going to take the privilege of being here to say that we are hiring. VoltDB is located in Bedford, Massachusetts. We also have offices in Santa Clara, California, for anyone that's desperately eager for more sunshine in their life. We work on a ton of really interesting problems. Well, you can read the slide too. So, anyway, feel free to contact me with any questions. This is an Arial slide. I don't know if this means, do you have questions about why there are a bunch of owls on the floor? I don't know the answer to that. But if you have questions about what we talked about or about Volt or anything else I might know about, I'd be happy to answer. So, thank you.
Before we move on, please give a great big round of applause to Ryan Betts, CTO. I'd just like to mention that if anyone has smartphones, take some pictures, post it up to the Meetup page. Everyone who is registered on the Meetup should be able to do that. So please pull them out and start snapping. And let's start with the first question. Yes, right here.
First, there is an advantage of VoltDB tool over a bunch of that the Microsoft SQL Server offers with BI tools and also in terms of SQL, I mean, it's all tools come together. What's the advantage of VoltDB in there?
So the question is, what's the advantage of VoltDB over, for example, a very mature SQL Server, right? Okay, that's a very fair question. So the core differentiation it's thank you, it's like basically setting me up for a pitch. So I didn't stage that question in the audience. The benefit of VoltDB is really the combination of performance with the ability to do transactions, right? So SQL Server is kind of a tool that has many different capabilities, from columnar indexes, right, to hekaton, to in-memory aspects, to a traditional kind of relational database. VoltDB is a tool that's specialized very much to be able to run some set of transactions very, very rapidly, right, against some incoming data feed. So it can give you some aspects of the performance of Volt, since that's one of its key advantages. A single VoltDB server, say like a 2-socket i7 kind of thing, can run a couple 100,000 multi-statement SQL transactions per second. Right? Each of those SQL statements each of those transactions is a fully serializable isolation transactional context, right? Full serializable isolation. That transaction throughput is being achieved in an active-active system, right? So synchronous replication within the cluster in a high availability configuration, all in a single data center. And you're doing millions of SQL statements per second on a single server. And you can scale that relatively linearly. You know, you basically like 85, 90+% of a server for every additional server you add to a cluster. A while ago, a prospect that we had never spoken to contacted us and said, hey, I filled up a Blade server with like 16 blades, I put Volt on it, and by the end of the day, I was running 6 million meaningful to me transactions per second, right? So it's that kind of capability just to transact basically until cows come home against a really fast data stream. We leverage that performance capability to solve problems like real-time quality of service against actual network packets in a network, or real-time denial of service attack detection against an ISP, right? Bring back metrics from all of the different endpoints and analyze them in real time, or really like the in-game analytics example I was speaking to. Anywhere that you have a stream of events or a stream of data and you can transact against it to produce decisions on a per event basis, VoltDB is well advantaged by its performance versus tools that are more mature and more broad like SQL Server. So SQL Server is a pretty awesome product too, but
well, it's all
Okay, the lady in the pink all the way in the end there.
Thank you. We were talking about just-in-time design. How do you do a project or business? What's the optimal way of working on it? When do you get started?
Okay, so the question is, how do you structure sort of hiring and scheduling kind of in a deadline? Or yeah, that's a good question. So I think that frankly, I think it's kind of a hard space to hire into because I think it's a very emerging space. Even the people who are kind of the quote-unquote experts in it are working with products that have only been usable for like the last 3 or 4 years in some cases, right? So I think you need to find people who understand distributed problems, first of all, and who understand how to find value by solving small chunks, right? And I think it's really more that character than any magic bullet. And certainly by just-in-time design, I don't mean that you shouldn't have a set of hypotheses that you want to test out. You absolutely should, right? I just mean that you should try to find value by solving small problems one after another. Because I think that you'll find that when I watch projects that go off and try to solve a big, large problem, they kind of not unsurprisingly fail, right? But when I watch projects with people who have a really identified pain point that they want to resolve, they can often apply specialization to resolve that pain point in a relatively smaller and successful period of time. So, kind of an answer. Okay.
Next question.
How much pressure does your clustering methodology put on the network? Did you guys use something off the shelf, something open source, did you use something off the shelf, or did you write your own? Are you using specialized network gear?
No, that's just basically SIG-E, 1050, TCP/IP between those, so a lot of clusters. We do find that the network can be a bottleneck. Like a Volt app, often Volt can transact at faster than Volt data off the network. So we're seeing in a lot of places more and more 1050 showing up, which will be leading to a lot of that. Also, but it's just all commodity. Yeah, that's a really good question. So VoltDB and Datomic have sort of very different worldviews, and I'm a total Rich I've never met him, but I love his talks. It's sort of aspirationally good sometimes. So VoltDB is all about how fast can you mutate your data, right? And Datomic's point of view is that why would you want to mutate your data? So they solve really different problems. So they're really at different ends of the spectrum. I don't personally know of anyone that's, and I'm not saying it's not because it's happened, I'm sure it's happened many times, but I haven't met anyone who solved a problem with Datomic. So I don't have any first-hand experience from the marketplace about what's been successful around that product. And that's by no means a criticism of the product, it's just, I just haven't been exposed to that. So I can't speak to real-world experiences.
Yes.
But really different points of view.
The lady in the blue shirt.
When would you use VoltDB versus a NoSQL solution? So there are similarities and differences between VoltDB and NoSQL. NoSQL is a really huge category, so when I speak about NoSQL, I'm going to kind of limit it down to the things that can compete against Volt, which would be more products like Mongo or Couch or maybe Redis, right? So databases that tend to be more operational in nature. And I'm going to set aside things like Elasticsearch or Hadoop, right, or graph databases, which also get grouped into NoSQL. VoltDB scales like a NoSQL system. It distributes data across a cluster in a very similar way to a distributed hash table system. Instead of distributing documents, or columns, whatever you want to call them, VoltDB distributes rows of a table. In addition to distributing rows in a table, VoltDB offers a strictly consistent access to that data with rich transactional capabilities. VoltDB is a fully in-memory system. The entire data set that you're operating against is in memory. It's made durable to disk through a combination of snapshotting and logging. So you could use VoltDB very successfully versus a NoSQL solution where you have a problem that fits in memory, typically a couple of terabytes or less, right, in the collective memory of a set of servers, where you favor a rich transactional scheme versus perhaps an eventual consistency scheme, right? So where transactions are very important to you. Those are typically the two differentiators.
Next question. Okay.
Yeah, so why not just use a more traditional ETL tool? Because while you're connecting these tools to sort of an ETL process, right, each tool is providing functionality that the ETL tool would not provide on its own, right? So when I talk about ETL, I'm really talking about the idea that you're going to flow data through a set of specialized systems. Each of those systems is providing some function that wouldn't be provided by an ETL tool, right? So VoltDB is providing the capability of transacting at high rates of speed to make decisions against an incoming event stream. Vertica or Netezza or Hadoop is providing the capability of exploration or analytics, right, in a really efficient way. It's just that when you begin to look at how they're all chained together, I was kind of terming that sort of chaining kind of a real-time transformation process, because data is flowing and that representation of data is probably being altered as a result of the computational process happening in each step of that pipeline.
Next question.
What is the largest database on OLTP that you have?
Specific to Volt or just in general?
Specific to your database.
Okay, so the largest Volt cluster, I believe, is roughly 30 nodes. I've lost track. And there are multi-terabyte Volt clusters in production. You know, we actually measure size more by throughput. Like, we're a system that's optimized for throughput and performance. So when someone asks me how big, the thing that's of interest to me is the maximum number of transactions. And I know off the top of my head, at least one Volt cluster that runs at roughly 400,000 transactions per second on a regular basis throughout the day. There are Volt clusters. Last time I added it up, Volt clusters were doing tens of billions of transactions per day in production. I don't know the current number, but that's a big number.
In the use case that you're talking about, right, could I use this system CEP kind of to do that?
Yeah, so where does CEP fit versus Volt is a very good question. I think that if you're looking at a CEP system as a way of doing kind of this pipelining process, we find that often Volt's capability of transacting against of CEP rates is a good competitive differentiation. There are specific cases and financial use cases where CEP is a great fit, where you need something like sub-millisecond latency is really important to you, or in certain fraud use cases where you would like to run tens of thousands of algorithms against every incoming data piece, right, where you're really not performing kind of a standalone transaction, but you're running a suite of algorithms, then CEP can be a good solution.
We have time for just one more question. Yes.
So what kind of SQL support comes out of the box for VoltDB? I believe that some portions of subselect are the only thing that are remaining to claim SQL 92 support for Volt. So we're at SQL 92 plus a few things. I think by the end of the quarter, thereabouts, we wrap up a few pieces of subselect that still need support, which is a huge improvement from maybe what Evan. So Evan's here. Evan was actually one of the original researchers on HStorm. I'm going to call him out. And I think when he left Volt, it was basically just CRUD, insert, update, delete. And now the SQL team regularly produces SQL. I have no idea what it does. Like, they could be completely lying to me in the Scrum reviews. That looks good. You know, they claim they know what answer is going to produce, but no, it's been a nice improvement. We used Volt a long time ago. I suggest the SQL has really enhanced substantially since then.
Okay, Ryan will be here for one-on-one questions, so feel free to come up. And thank you, Ryan Betts, CTO of VoltDB.